Hello guys, this is Dushin from How to Rhino. We just crossed 10,000 subscribers here on YouTube, and I really wanted to thank you all for your support, for your likes, comments, for sharing this content, and also wanted to thank all our Patreon supporters, without which help this channel would not be the same. So again, thank you, and as a sign of gratitude, we prepared a special giveaway that we'll announce on our Instagram page, so make sure to go there. It will be announced in a couple of days. Alright, so let's jump into tutorial and let's see what we have prepared for today. Okay, so today's tutorial was inspired by this project. It's called the Joshua Tree Residence, designed by Whiteaker Studio, and it's located in California in the United States. So here in this definition, we went through the creation of a similar geometry that is shown here. So we didn't recreate exactly the same house. We just used this as an inspiration piece, inspiration concept for the definition. So today I'll just show you how we can achieve this randomness and how we can achieve this extrusion of all of these elements. Okay, so let's dive right in. So let's turn off here the preview so that we can see how we start with this. So I'm gonna disable these swatches, and we're going to start from scratch. So here on the left side we have one single point that's located here, and we have another point on this side which is going to be on the other side. And what we did here, we used vector 2 points to show the vector, to create one vector which is going to be from this point to this point, and that's what is shown here. And then we used this vector to create a plane. So we have a vector and we have a plane here. Now the next step here would be to create a rectangle on this plane. And this is the final result that we got here. So this is an additional plane from which we'll start the creation of our rectangle. And you can see here that we used the expression of -x divided by 2, and we used point-oriented components so that we create this rectangle so that the midpoint is in fact where this point is starting. So that's why we have these elements here. They're all just allowing us to have our rectangle in the middle. So once we have our rectangle in the middle, this is, let me just hide these guys. Okay, so we have the rectangle, we have the vector, and we have the lines. That's the first step. So now when we have the rectangle, let's see what is here on top. Here on top we have a range, and we gave it some numbers. We gave it numbers here. Let me just show you. Type panel, and we used all of this for the degrees. So we have here 11 numbers, and we gave it from 0 to 360, but we used here a call index to take the 0 out, and that's what we did here. And we finished up with 10 numbers without the 0, so it doesn't repeat itself. And then we divided these guys into 2 segments. So we used a list item here to segment this list, and we said, okay, on this list I want first 3 numbers, and on this list I want everything except those 3 numbers, which means I want everything that is left, which is these guys here. So here on the top we have first 3, and then on the bottom we have the rest. The main reason why we are dividing these numbers is the following. Let me just show you this. Let me uncover this. So if you can see this, so this is going to be the first layer, or the first set of geometries that we are creating. So if you take a look here at our example, we wanted to keep this angle, and that's why we have similar effect here. We have these 3 elements as the fixed ones, and then everything else above is going to be randomized. So that's why we divided that list in different segments. So let me show you what that means. So let me disable this again. So we have those three divided, and then here we have all the additional ones. And what we did in this area here, we just created some random numbers. We put the list, and we gave it some seed. And what this gives us, it gives us some random numbers, which then we can use to add to this list, so that we finish off with a bit randomized list that looks like this. So you can see here at the end, when we use the merge, we have these three numbers that are going to be our first three geometries that are there that we don't want to change. And then we have the other list, which are the same type of angles, but slightly different. You can see that now we have numbers which are a little bit different. And the whole reason why we're doing this is because we want these angles to stay fixed. So these ones will stay fixed, and then these ones will get a little bit mixed up. So that's the concept. Then what goes next? We come here and we use those numbers, and we use those as radians so that we can do some rotation. So let me show you what this means. If you remember here, we used that point, and we used the geometry from here. We use this plane to make a simple rotation. So once we do the rotation, you will see that now we have the rotation in the x-axis. So it's rotating around the x-axis, but we're using here the z vector to define it. And now at this point we have a lot of these rectangles. You can see we have 9 rectangles, but we still have that division. So 3 of them should be the first 3 and the rest should be the other ones. And this vector would allow us to create normal planes onto these rectangles that we just created. So let's see what's going on here. We took those vectors and we brought them down, and we said, okay, I want to create those planes from those vectors. However, this is when we have a little bit of a problem. So let me just hide these for a second, or yeah, let's skip them. So you can see that now if you go to the top view, they're exactly following that plane, and that's what we wanted. However, you can see that these planes are not all created in the same axis. That's why we need to orient them. That's why we use this process here to orient them. So let me show you what I mean. I'll just temporarily go to shaded mode so you can see it better. So you can see that now they all have the Y in the same in pretty much the same point, the same line, but we don't want that. We want it to be oriented below so that we can assign a better rotation for it. So we click the preview, and now you can see that all the y-axes are in the correct position. That's what we wanted. And the way that we did this, we just used one of those planes and we did deconstruction, and we said, okay, I want y direction to be the one that will determine the y direction for all of these planes before, and that's why we get this result. So I'm saying here, okay, just give me the inputs of all the other ones except these 3. And what we need those y values to put here in the rotation. So what is this area here? This area here is simply going to give us again some different angles based on different numbers. So we have a lot of these numbers here, and then we have here these are actually degrees, and then we convert them to radians, which would go then into the rotation component. And then we are rotating these planes, these rectangles, to get this final result. So now I will show you what we got. So we did this to get the rotation of these rectangles like this. So you can see how these planes became oriented in a different way based on this rotation axis. So we just did the rotation around x-axis, and now in addition, like if you want to create another layer of complexity, you can use that, and you can use pretty much the same components here, but use also the values to orient it in also different axes. That means that if I uncover this guy, you can see how now they are rotated also on another axis, not just this one. So from this, you get this, and that's the result that we were going for. All right, so what we can do here, we can hide this, and now we have here the seed which we can play around with. So we can see I want a different kind of rotation, and this is how my rectangles here are going to rotate. Okay, so that's what you need to know about the rotation. Now let's come back to see what's happening with this first three inputs that we have here, these three. So these three are going to go into this element here. And the whole idea here is to create this kind of effect. So this is going to be something that is resembling these kind of elements, but of course we want to keep, as I said, we want to keep these three as constant. So we have this one, and this one. They are using those same angles that we gave it. So what's happening here is that we have those rectangles, just like they're shown here. So we have these rectangles, and then we're saying, okay, I want to extrude them, but I need to have the direction. That's why we're using amplitude, and we're using this vector to tell it, okay, this is the direction into which I want you to extrude these guys. And now this part here is going to tell us, okay, what is the extrusion distance? This is the extrusion distance. And we have one more element here, which is called insert items. And what this does, this gives us the control of one of those elements. So we want to randomize the extrusion distance of all of the other elements, but we want to have the control of just a single one. That's when you use insert item. So let me just show you what that means. This is a simple list that we just pulled from this random seed here. And this is the list, the same list, but we insert one number here, one item. And that item is shown here, 6.624. It's located here. So we just said, okay, I want to have the control of this guy. So that's why I just want to have, for example, this slider so I can control it. I'll show you later why. So that's the idea here. And now, for example, if I change the seed here, you can see that how all of these are going to change, but this guy here, the location is going to stay the same. And only if I move this number here, it will change, as you can see. Okay, so let's bring it back. And the reason why I want this guy to be exactly here is because I want to follow this example, and I want to have, okay, this guy, the extrusion distance should be exactly there, so it meets these ends. And that's why we want to control this one. And of course, this one can be randomized, as you can see, and you can see this in the example. And here we just have the extrusion, and then we have the cap here. Okay, so let's hide that, and let's come back here to see, okay, what's the next? So if you remember, we came until here, and we created some of those randomized panels. Let me just turn off the panels now here, from here. Okay, and here we have the fun part. So we have here, if you take the list, if you see, we have here 6 rectangles. But for example, what if I don't want all 6? What if I just want some percentages of them to extrude? That's where you can use a random split list. And what it does, it gives you the 2 lists which are going to have specific rectangles to them. So this is one, and this is the second one. You can see that this first one has 4 rectangles, and this one has 2 rectangles. And now we choose whichever we want to go with, and then we do the extrusion for that one. So for example, this is how that would look like if we chose the top one, which is the 4 rectangles. But if you want to choose some other kind of split combination, you can just go here, and you can see how the relation between the rectangles would change. And then you can experiment and see whatever works for you the best. Now when we chose, okay, we said, okay, we want to go with this one. This last part is pretty much determining what is the plane onto which I want to extrude my rectangles. We're giving it a vector, which is going to be a normal to all of those surfaces. And here is just, again, a random extrusion. So we give the amplitude and we give that to the extrusion, and we get something that looks like this. And of course, if you want to play around with this, you can change the seed and you can see how the extrusion distances themselves are going to be changing. And at the end, of course, we cap the geometry and we have that final look. Let me just turn on this guy and let's turn on this guy. And let's go to the to our style, and I think we're ready. And that should be, yeah, we can now hide everything else. Actually, this was supposed to be yellow, sorry. Okay, so yeah, this is our final result. And as I said before, you can modify this. You can play around here with the difference in extrusion. You can also play around here with the amount of these guys. You can play around here with the orientation. You can play around here at the top with these guys. So that's all you can control in this definition. So that would be all for today. Once again, thank you all for your support here on the channel, and special thanks go to Marlon, Scott, Elton, Simon, Samantha, Frano, and Ryan. You guys are our new Patreon supporters, so thank you a lot for supporting us. If you'd like to get this definition and all the other project files from all of our tutorials, you can do so by becoming our Patreon. The links are below in the first comment and also in our description. So that will be all for today. Thank you for watching and take care.